Hello, and welcome to the 13th episode of Cycles Podcast. Today we have Derek Chamorro, and Derek is a staff engineer at Cloudflare. He has over 17 years of experience designing security frameworks at scale. His main focus is on research and development within infrastructure and cloud security, and he currently holds multiple patents. And I actually saw, well, I see your patents are behind you.
Yeah, so like I started getting these these plaques because I realized my previous company didn't give you squat. You figure you like get like a nice little award. I think they give you like $100 and I'm like, great. So I've surrendered my IP to you and I get $100. So like gifts from my wife to, say, hey, you feel really accomplished. So I got to figure out where to put the rest of them. So I figured I'd start.
And and I saw you post those on LinkedIn yesterday, and it's really interesting because for everyone listening and watching this, obviously you're familiar with Cycle, but what you might not know is that sorry, there's no way you know this. This is there's no way any of you know this. So let me clue you in here. Back in 2015, when I started building Cycle, I had for many of you who might know this, I had already been working in infrastructure. I had worked at a company called Single Hop for a few years, where we were working with QEMU, we were working with OpenStack and a number of other technologies, but that's where we started to see Docker and this whole container movement come, and we started diving into that with obviously what has now become Cycle. But in the early days of Cycle, while I understood the principles of a lot of these foundational kind of ideas and concepts and things, I wasn't 100% sure how to implement them. So I was sitting there, this is again back in 2015, watching YouTube videos, trying to figure out how VXLAN and all these things ended up working. Long story short, it led me to meeting Derek. And so for everyone who's using Cycle today, Derek spent, I don't know, it was 2 or 3 hours on. I remember it was like late at night. It was 2 or 3 hours
Yeah.
just walking through some of these really weird. Like we had like some IP conflict or something where we had like a loop in traffic where it was just constantly getting worse. Like I remember like we had sent like 2.5 terabytes of data, through
Yeah.
like a private network, and just things started getting saturated. Like, oh man, it was.
Yeah, it was fun because of like unique issues and again at the time we were just kind of screwing around because we were doing a lot of testing. I think I was working at Cisco at the time. My buddy David, who was doing the YouTube videos, was working at HP, and we're both kind of like VXLAN was relatively new, so we figured, hey, we're screwing around, we're trying to see what works. And then you came with some like unique problems because again, it's not something that we'd seen before, but typical kind of almost like spanning tree loop kind of issue that you would see in a normal layer two network is kind of like the storm cloud that you were experiencing then. So it's like it was fun. It was fun to like work through them and kind of figure that out. So little did I know that it would grow into the company you have now and help a little bit with your success. So I feel good. I feel like I did something good.
Well, I mean, it's nice. It feels kind of like a reunion, right? Where
Yeah, yeah,
7 years have now passed since
yeah,
those initial conversations, and I mean, we've seen each other's stuff on LinkedIn and things like that
yeah,
over the time. But it's nice to be able to have this. Like I said, it's kind of a reunion of going from hey, I really need help solving this problem because I don't understand it, to
yeah,
what Cycle is today, where we have hundreds of servers connected to the platform and people are building
yeah,
like some really cool things on the platform. It's always neat. Like it's it's neat because obviously time's always a bit of a blur. There's always so
yeah,
much happening, but it's nice to be
yeah,
able to take a step back and be like, wow, how much has actually happened over all that time. So you mentioned that you were working at Cisco at the time,
yeah,
and correct me if I'm wrong, but uh, well, I guess rather than being wrong. So after
yeah.
Cisco, you work at Cloudflare now, but where were you working
Yeah.
in between?
I did a few stints at eBay, and when I say few, I did three. For some reason, I just kept on going back. But in between that, I worked at Atlassian. So just kind of focused on this cloud security model. Again, it was interesting because most of cloud security was just focused on the big cloud vendors. But coming from an OpenStack world, anybody could effectively run their own private cloud. So you were always trying to do this service parity comparison between what was being built within the major cloud providers as well as what you could build on prem, and it was almost like I was playing this game of catch up. So where eBay still runs a very large OpenStack environment, they've been trying to containerize and trying to make services smaller, but obviously having to refactor. thousands and thousands of applications is a big challenge for them. So, you know, understanding that there's players in the space that could actually probably help them is, probably would be the direction they hopefully one day they might go in. But yeah, no. So focused on cloud security, and then eventually led my way to Cloudflare. At the time, it was like a small security team, especially on the infrastructure side. But Cloudflare is different because they are kind of like a services provider. And being in that provider space, usually you have your own hardware. So they didn't have a dedicated like hardware team or hardware security team. And so where I found the need, I kind of pivoted there. So like server grade hardware, I hadn't dealt with in a long time. Most of it was like OEM off the shelf type of stuff. But then realized, oh wow, these are some of the capabilities that we have. Let's take more advantages of what we currently have within some of these existing SKUs, and then plan for how we can build our hardware better. A lot of times when you're trying to pull things like entropy from compute, you're pulling it from like known sources, but literally you can pull it from some of these microcontrollers or security processors that you have on a system. So that's where we're trying to take more advantage as far as like the hardware that we build, making it more secure, but at the same time also leveraging stuff within hardware and dedicating more compute to our services.
And as we talk about hardware security, obviously, I think the first thing that comes to mind, and I know this is maybe I don't want to say abstracting, but maybe watering down some of the projects that you're working on. But I think a lot of things that most people immediately are familiar with is like the T1, T2 chip, or what I believe that's what they were called,
Yeah.
inside Mac computers these days, where you were actually moving a lot of that hardware, or sorry, a lot of that security components outside of just software into hardware.
Yeah.
And so with the efforts that you've been working on recently, I know there's a number of things you can't share, but
Yeah. Yeah.
what can you shed some light on some of the problems that you're solving?
Yeah, absolutely. I mean, one of the big things is like image provenance or like provenance when it comes to firmware components. It's pretty easy within like a build system to be able to say, hey, listen, I want to sign this artifact or this piece of software or this package, and then from there be able to have this trust chain as far as what was implemented in order to be able to validate that signature, validate the certificates associated with that build system. It's really really easy. Firmware is a different beast. This whole concept of root of trust and where it's kind of anchored to is kind of like a really big thing. So we got really good at secure boot, but we started saying, well, there's other components that load that effectively just boot up prior to your OS ever booting. So how can we secure those? And it's been kind of inconsistent all over the place. So primarily is consistency and being able to develop that signing framework, and then working with vendors to kind of like make this a little bit more standardized, because it seems like every vendor wants to have their own. And when you look at a motherboard, every single module can effectively be its own security subsystem, and they don't talk to each other. And that's a problem because now you're managing different processes and procedures for every single module they might load. And we think about things like data processing units like DPUs, they're their own server. So you plug that in, now you have another component that is effectively just, running its own security that might not talk to anything else. So, I mean, we're really big on kind of like having identity models and being able to like, pass tokens and whatnot. That doesn't exist in the firmware world. So how do you build trust in that? And that's kind of challenging. But we're looking at ways to be able to do that. We're really big on blogging about it. So I would say like just keep your eyes out, and we'll probably have some really good blogs about that soon.
And so, if the at least from my knowledge, if so, actually, let me take a step back. So with the hardware security components that we're talking about, are and you talk about signing certificates and things like that. Are again, maybe to generalize, maybe too much.
Yeah.
Are you using hardware to increase the security and integrity of the software running on it? Which I mean, I'm guessing that's some part of it. Or is it more about verifying that other hardware components on that machine are acting the way that they should as well? Like,
It's kind of both. I mean,
okay,
one is to be able to validate that what you received is actually from the vendor and that it's in a specific state, and then you're able to like validate that. And then the other one is forming kind of like this boot chain. If there's a kink in the boot chain, the rest shouldn't be able to work. And at some point, you should be able to fail that. And that's kind of like the concept of secure boot. You pixie boot a server, you run through these, chain loaded scripts, and each one of them gets signed. If there's a, failure within some option ROM that you've been able to pull from some module, then everything else should fail. It shouldn't continue to boot. And that's the idea. At some point, you have trust built within your chain. If you don't trust something, then it stops, and then nothing should proceed. Hopefully, it stops before there's other components that are loaded, and I think that's some of the logic that we build into kind of like that process. But yeah, it's a bit of both. It's who do you how do you trust the manufacturer? How do you trust the state that it came in? And then from there, how do you trust any adds, moves, and modifications you've made into that chain?
Got it. That makes a lot of sense. And so with the projects that you're working on, I'm guessing that a lot of the requirements for what you're building, I mean, obviously it's beneficial to the industry as a whole,
Yeah.
but have you seen any very specifically like highly sophisticated attacks that have started making you consider, oh, like we didn't think about needing to secure this specific component or take this specific process. Like I know
Yeah.
that's kind of a weird question, but I guess the
Yeah.
question is I know there's a spectrum, right? There's a whole bunch of people out there like script kiddies or whatever
Yeah.
the proper term is today, where it's just like, hey, we're just proxying or we're just spinning up bots to see if we can connect to an open SSH connection and
Yeah.
brute force our way in. And on the
Yeah.
other side, there's super sophisticated attacks happening,
Yeah.
and just curious what you're seeing in the industry.
Oh man, so like yeah, so it was back in 2017 that we started seeing a huge uptick in firmware and hardware type vulnerabilities, because that was kind of like when you saw a lot more IoT devices that were made available, and outside of anybody that can just take a Raspberry Pi and build put a Wi-Fi module on it or just build something that's already automatically connected to the internet. I mean, you look at some of these like baby monitors or your fridges or anything like that. A lot of these are just running some kind of ARM component. And what they realize is that it really doesn't matter if you're running a server grade ARM component or just a small little, Cortex A3. They all are very similar. And so, it changed the landscape because people could buy these little kits relatively cheap and look for vulnerable firmware. And they were looking for some kind of, remote code execution that was capable of it. So all of a sudden, these devices are turned on the internet, and they said, if I can attack this small little processor, can I find the same equivalent within, a server grade, or, ARM processor? So, we were seeing that, and don't get me wrong, the community's been really great at, putting, different types of extensions and security extensions on these processors, but it made us realize that, it wasn't, the fact that we have a data center and the fact that we have, servers in there under lock cage, we couldn't protect them necessarily the same way. We had to think differently, and so that's why. It takes script kidding to the next level because it didn't require a ton of sophistication to be able to determine that you could actually break a piece of firmware, download it from an unprotected, storage mechanism, and then from there maybe make some modifications, put some implants, and now you have persistence. And so that's kind of like been the huge concern is that if there's some level of persistence that we haven't been able to see because of some vulnerable piece of firmware on our systems, then we're put in a bad spot. And so it brought kind of like this give us brought a lot more attention to kind of like this problem and ensuring that we're solving it at scale and in the kind of like more like at the server level.
Got it. And so, I mean, I guess that kind of leads to, the next question of what are your thoughts on, for a long time we had generalized compute, right? It was hey, here's a processor,
Yeah,
do whatever you want with it, and we keep moving
yeah,
more and more towards very, uh, sorry, what's the right word? I don't want to say specialized compute, but maybe that's the
yeah,
best term of building processors for specific tasks.
yeah.
And with what you're doing in the hardware world, interested to hear your perspective on that as well.
I think it's great because now we can do things like set like specific type of affinity for specific cores to specific processes and whatnot. I think the challenge then becomes is that I feel like the world is more moving into kind of like the ARM realm, and so based off of the reduced instruction set, there's a lot more that you have to develop, and there's a lot more that you can actually miss. So I think in some ways it might make it we have the ability to be able to make it more secure, but I think it's still to be determined because again, we're still getting to this like server grade ARM environment that can actually handle like the request per second we expect to see, the amount of traffic we expect to see. And at the same time too is like if we choose to set affinity to these type of processes, do we truly keep them isolated? There's a whole new slew of security extensions that are kind of hardware dependent in the ARM V8 world. So it'll be interesting to see because they're just now coming out, and things like branch target identification, memory tagging, allowing you to be able to specify the actual memory stack that's associated with a specific application process that's running, and then ensuring that the target identifier is unique. Things like pointer authentication too. But again, really cool features to implement, but at what overhead? So are we gaining anything by implementing these things, or are we just adding more overhead and expending more compute for something that really not might make sense? So a lot of stuff to test and see if it actually works. But yeah, so yeah, it's still to be determined.
And with the so along that same line, do you happen to be a Mac user?
Oh, absolutely, man. I mean, I think it's I tried using a Pixelbook, and then I was like, man, this is great, but everything effectively everything's a container, and so now I'm just running really fat containers. I'm like, I'm not sure this is actually the right way I want to go. And so it's funny from a developer standpoint, the world is still run by Mac, and I'm still an Arch user. I still use Debian on like my lab and stuff like that. Arch obviously has all the kind of like pre-release builds you want to see for like any new daemon that's coming out and stuff like that. So, but it's a lot of work, man. Like Macs are just easy. So it's like I'd
It,
rather
it
just go down. And yeah, the new M1 chip, man. Like that battery life is like great. So like you can't beat
that,
that.
that's exactly where I was going with it. Like as we get into specialized
Yeah,
computing, like it's so I don't know if you run it on your machine, but I've been using iStats for a number of years, where you can see
yeah,
temperatures of different
yeah,
processes, or sorry, different
yeah,
components in your machine, and it's always been really neat having going from with an Intel machine where it's just it's just a core is a core, right? Being
yeah.
able to have energy efficient and performance cores, and being able to like track the usage of those, and the battery life, it's insane. Like have you
It is
actually
absolutely
played around
insane.
with one of the have you played around with one of the pros yet? The M1 Pros?
No, I know I haven't. It's like I'm still on this waiting list at work in order to be able to get a new one, and so it's like I'm dealing with like an old computer. Personal computer is, but like I'm dealing with an old computer. I'm like I beat this thing up, and but the interesting thing about it is like people say it doesn't come at a cost. CIS versus risk architecture is different, but in the sense it's like there's a really great analogy that I heard the other day. It's like imagine that you are cooking a meal, and then complex instruction set architecture is tells you exactly everything you need to know, not just to cook that meal, but how to use a kitchen. And I'm like, oh, okay, that's a perfect analogy. Risk will tell you exactly how to heat up water, how to use a pan, and how to and then where your ingredients are. Everything else has to be mapped. And I'm like, is it really that bad? And working with some of our system architects, I'm like, oh my god, like the amount of rewrites that we have to do for a lot of code is ridiculous. But the trade off is lower thermal density, power, lower power consumption. It's like if you could save 30 to 40% in power alone, I'm like, that's how much money do we save worldwide? And so like those are the benefits, but at the same time, it's like, yeah, it's a pain getting there because you have to write specifics on how to use specific instructions. So yeah,
It is, and I mean, I've noticed with the different kind of side projects and things that I'm working on. Um, I mean, well, it's interesting the compile time differences.
yeah,
Obviously, that's only a part of it, but the compile time differences of native languages versus some things that have to be like. I mean, if you're obviously there's a lot of extra overhead if you're running. I don't know if you've run like Docker on an M1 yet, but if you're compiling for Intel on top of Rosetta on an M1, the compile
mhm,
time skyrockets, right? I don't know if you've
yeah,
experienced
yeah.
that yet, but it's oh
I
god,
haven't.
it's terrible. But
Mental note now.
everything else has been phenomenal. Like
Yeah,
I mean, building like native like ARM Golang applications. Like everything I do is Golang these days.
yeah, yeah.
And it's just been like I mean compile times. Like if you're doing native compile outside of a container, oh my god, it's amazingly fast. And so
Oh wow. Yeah.
I'm super excited for the as I'm super excited for the future as we continue. Like I think that sorry I'm super excited for the future and where we're going with specialized compute, but at the
Mhm.
same time, right now we're living in this weird kind of world where, like, for a long time, I feel like even if you get better processors, like, people just keep building shittier code, right? To the
Absolutely.
point to
And
where it's like, the browser's like, oh, I used to be efficient, but now I'm using 10 times more RAM, right?
yeah, exactly. I think that was the point. It's like we got way past Moore's law because we started doubling compute at such a fast pace, and now it's like more about efficiency. So how can we be more efficiency with the cores that we have? And it's like, okay, we can take some good things that we learned from browsers, but if we're just stacking shit on shit, then we're not really gaining anything. And so it's like, yeah, because like, effectively, especially if you're constantly, using applications in and out, and all the IOs associated with that, you have to rely on garbage collection in order to be able to do a lot of cleanup work and stuff like that. It's just, yeah, I mean, you're not really gaining anything. It's more or less, do you rewrite stuff to be special purpose and be more efficient, or do you have some kind of other routine that's actually, being more effective at either your GC process or whatever? So yeah, no, I completely agree, man.
But it's I mean beyond all that, it's like we're at that weird time right now where we've had enough of an advancement in these M1s and stuff
Mhm.
that like shitty code hasn't caught up to it yet. Like so it's
No,
like
not at all.
we have this like it's like suddenly everything is fast again, but you kind of have to expect that people are going to keep just writing bad code, and to the point that you made of you just constantly stack stuff up, that even with this new gains in performance and things like that, we're going to end up in the same situation again.
Oh, absolutely. And that also introduces like a whole new slew of vulnerabilities. I mean, like if you look at some of the latest kernel updates, some of the latest like kernel security updates, they were associated with compatibility mode because like, we just forgot that we were still using 32-bit architecture. So we had to have this like backwards compatibility that effectively, opened up, a whole slew of vulnerabilities that were found over the last 6 months. So like now we're out, running, a lot of patches, and, because we had to, because these features were set because we weren't ready to make the jump into 64-bit architectures completely. So yeah, it's like we made the jump, but we forgot. Oh, we wrote that, and we added this compatibility mode, and we just kind of left it and just never changed it. So it's like, yeah, you have to do a lot of cleanup work to make more sense of it. And so yeah, it's horrible.
I feel like at some point we're gonna have to have like this great reset. Like I thought ARM could be that, and I'm not giving up hope.
Yeah,
But
yeah,
at some point we're gonna have to have this like great reset where it's like, all right, we learned a lot of the last 20 whatever years of doing these things.
yeah.
What can we go back and just instead of worrying about legacy and dependency stuff, like what can we just start new on and do right from the start? Although we're gonna have other issues and things that come out of that anyway. So
Oh yeah, I
um,
mean, oh yeah, it's like, oh man, like I just want to build my new house and just call it a day and stuff like that. Oh, but no, like my house was built in the 80s and I still have to attend for like, shifts and like stuff like that. So it's just like, everybody would like to have built that new house, but reality is that we live in older houses and we have to maintain them. So yeah.
Yeah, and so switching gears a little. So obviously you had mentioned earlier that you work at Cloudflare, um, and so I know that Cloudflare's been in the news a lot recently with
Mhm.
all of the conflict happening over in Eastern Europe.
Yeah.
And there's a number of articles that I've read over the last, I don't know, what has it been, almost 2 months at this point,
Yeah.
about, companies relying on Cloudflare for,
Mhm.
with an increase in attacks, Cloudflare being
Yeah.
there to handle the DOS attacks and, some of these other intrusion type attacks.
Yeah.
For as someone as someone in Cloudflare,
Mhm.
what has that been like?
It's been chaos. I mean, those first couple of weeks I think we all felt the same way as like the rest of the world, like what is going on, what is happening, and then seeing it from a network perspective. Our CEO made like a really really good post from a lot of collected data regarding like network traffic. And so we could see what areas were being impacted war wise from the network traffic that was occurring, and it's different because normally you would probably see that. Oh, okay, there was like a power outage, but it was a blip and whatnot. But there were like these brownouts and there were these dips and then there was these traffic shifts that you could see. So you could kind of tell, oh my goodness, this is actually associated with that as opposed to something that would be like a normal DOS or like a normal power outage or normal brownout. These were indicative patterns of like, oh, something bigger is happening. And so from the inside and being able to see some of this actual live data and stuff like that, it's been pretty crazy. Even more so because like our network has been pretty resilient and like we're still be able to keep the lights on and see that we're still protecting people out there too. Our warp service, which is a VPN service that runs through our network, it does like intelligent routing and whatnot, but uses WireGuard technology in the background. Became like a huge downloaded app in Russia, and because people wanted to be able to connect out and actually be able to see what was actually going on. And And so, it gave us like a different set of pride knowing that, hey, we're protecting a lot of these sites and we're protecting a lot of these agencies out there to kind of keep the fight going. And so, yeah, uh, this first couple of weeks were, I mean, I'd be lying if I said I didn't, look at my wife and cry where it's like, this is real, this is real. And then that sadness kind of changed to like pride because knowing that all the work the collectivity that the entire organization is doing in order to be able to protect information and protect freedom to that information and access to that information. I think made me feel really really special. It made me feel like I was contributing to something that was part of the greater good.
Yeah, and it was interesting. To so many of the points that you made. Obviously, I'm not I don't work at Cloudflare,
Yeah,
but I've owned stock in Cloudflare for a long time,
yeah.
and it's I one of my investment philosophies is I only ever invest in companies that I use their products,
Mhm.
and so like I use their products on at least some sort of weekly basis, right? Like
Yeah,
that's then yeah, everyone has their own investment philosophies, but
yeah,
that's mine is I have to use the product for me to invest in it.
yeah,
And but after reading all those articles, and I mean again, I don't work there,
yeah.
but having money in a company that was helping maintain to the same things that you just mentioned, uh like it was I mean I'm sure the pride was not close to your pride, but there was a little bit of it. It's like, hey, I'm glad to support this company, right, is
Yeah.
really I guess what it came down to. And so the types of attacks that were happening, was I'm guessing a lot of them were generalized DOS attacks where it's, hey, let's try to saturate that infrastructure, etc. But with everything that was happening, were you seeing a lot of much more sophisticated type attacks happening as well, where people like I mean where you could kind of maybe I don't know if you knew for sure, but where it's like okay, that is obviously a very specific targeted attack on that resource, or was it more higher level generalized than that?
Yeah, it was kind of sort of related to that, where we started seeing more sophisticated attacks. It actually occurred recently. We mitigated. It was like a 15 million requests per second DDoS attack, which was unique because a lot of the like layer 7 type attacks we see are usually HTTP based, and this one was HTTPS based. And for those that kind of know or maybe not know that HTTP DDoS attacks are kind of rare, but they're also really a lot more expensive in terms of the required computational resources because of the higher cost of establishing a TLS, encrypted connection. So it costs the attacker more to launch the attack, but it also, costs the victim, more to mitigate it. So, normally we said we see these large unencrypted type of attacks, but this one stands out because, again, it being HPS in nature. So, our logic picked it up. It only lasted, I think, like 15 seconds or whatever. But so we don't know if it was like some kind of reconnaissance attack or if it was an active attack and saw that it stopped because we were actually stopping that. But yeah, it's very very expensive. But we assume that we'll probably end up seeing more of these in the future because if somebody's can say, hey, listen, we're going to expend our resource or we're going to expend money just to bring you down. It's not just us as a provider that's going to see it. We're going to see it, through a swath of providers are probably going to be looking at these.
And as we throw around the term, a DDoS attack,
Yeah.
for anyone watching or listening to the podcast that might not be familiar with that, would you mind giving a quick high level, dive into what a DDoS attack is?
Yeah, yeah. So denial of service attack is an attack. It's an attempt to disrupt what we consider as being like normal traffic to a server or service or network, and this is done by overwhelming the target with a flood of internet traffic. So they distributed denial of service attacks is not just coming from a single source but potentially many, many sources, and not just in the realm of like hundreds, but thousands or millions. And usually, these sources are compromised systems that are used as sources of attack, or exploited machines. We've mentioned before IoT devices. IoT devices have been a great launch point for these type of attacks as well. So um, the analogy that the company gives and that I like to give too is is imagine, you're on, a 2 lane highway or 3 lane highway, and there are, all of a sudden many cars that are just driving down that. So your legitimate traffic that's trying to go through there, or a bunch of cars that have no purpose, that really have no direction, that are just changing lanes or whatnot. So now your car of normal traffic is trying to get in. It's going to be very difficult. So they have this highway is effectively flooded with a bunch of cars that are driving in all different types of directions, and your legitimate car of traffic is trying to get in. It's very hard. So
And so one of the things that I've encountered, and I'm sure you've encountered it in this industry as well, is people who might be new to infrastructure. As they talk about the DOS attacks and things like that. It's what software can I install to mitigate a DOS attack, right? It's something that usually you have, again, junior system administrators, things
yeah,
like that, people
yeah,
who this might be their first foray into a DDoS attack.
yeah,
And as we both know, you can't solve a DDoS attack with software,
yeah,
right? It's all about how much computational power and things like that can
yeah.
you use to filter and clean the traffic. So I know that Cloudflare, that this was the bread and butter of
Mhm.
one of the initial offerings that Cloudflare really grew on.
Yeah.
Uh, would love to hear your take on that.
Yeah,
Or
it was
or
actually really cool. Yeah, yeah. Working, I come from a service provider background, so I've worked for a lot of big, really big telcos. And normally, we would always say, hey, listen, we're just going to network wise, offset the traffic, or quarantine the traffic somewhere else. We use some BGP and Anycast technologies to be able to do that, but it's almost like dedicated special purpose hardware. So Cloudflare was the first company that when I came here, I'm like, it's just an intelligent way of being able to do that, and it's using some secret sauce in the background. But the idea is that this secret sauce runs our entire edge, and so as you distribute it through hundreds of different locations that we're at, it's my security philosophy. It's like, let's make security smaller, and the reason being is because if you make it more portable, it's easier to adopt, and it's easier to transfer, and it's easier to implement everywhere. And so that was the idea. The idea is it's some simple logic in the background that's actually working, that that's very effective at detecting when an attack is actually occurring. So it'll detect suspicious amounts of traffic originating. It'll sample. It detects for these type of floods or unclaimed surgeon requests to a specific endpoint or series of endpoints. And it's all this logic that's actually built in that made it really effective product. And it's just grown immensely over the years. It used to be something that I thought only focused on network layer attacks, but it's extremely effective at application layer attacks. And so yeah, I mean it's crazy because I found out about this attack that was stopped because we blogged about it. But at the end of the day, it's like, it's not like all systems go. Let's all hands on deck. Let's all panic. No, it's just because the system works. And so I'm still floored by it. But again, I guess you got to be proud about a product that works when you really don't hear much about it until it's like in the news. It's like, oh yeah, we did that. Okay, cool.
Well, and on that question, and I don't know how much you'll be able to share about this, as it might start to get into that
Yeah.
secret sauce,
Mhm.
type answer. But within Cloudflare, as you start to handle these attacks,
Mhm.
and as we just talked about, how it's the hardware itself is what helps actually filter and, let's say, sanitize, or whatever the proper term is, that traffic, so that way valid traffic still gets through, right?
Yeah.
But so with that infrastructure that you have to do that, I guess my question that I'm getting to is how much of that is like always there versus auto scaling type into, like is it always like, is it, I guess the infrastructure nerd in me is like, how
Yeah.
much bare metal is sitting around to handle this
Yeah.
versus how much like cloud compute across number of providers is being brought in to help mitigate these types of things.
Yeah, it's interesting because like when you're used to like the cloud service provider mentality, it's like, oh no, we have an auto scale group that will make the auto scale instances in order to be able to meet the demand and stuff like that. We just run a very large infrastructure because we know, we do a really good job of capacity planning to determine like, oh, how much capacity do we need, and what do we do. And we blog about this, but we're really good at being able to distribute traffic. And so distribute intelligently, even if it's network traffic, even if it's like, attack traffic. We're really good at being able to say not one location is getting overwhelmed or overhead, but we just know how to distribute that load. That's the beauty of like things like Anycast and some of the technology that we use is that it doesn't get focused on one specific area. It's geographically dispersed, and so it makes us not susceptible to have to say, oh well, we need to. You don't have like some tech guys there that are racking a bunch of servers in order to be able to meet this demand. It's just it auto scales automatically to meet our demand because we're really good at we're really good at handling packets, and so like because of that, kind of makes us a little bit more resilient to what other vendors might experience.
But that infrastructure that you're using to filter and route that traffic and things like that is all fully owned and maintained by Cloudflare, as opposed to
Yeah, yeah, yeah,
you're not
yeah.
using any external cloud providers to help
No, no, no.
manage
This
that
is
stuff.
yeah, no. This is just us. This is just us. We have excellent hardware infrastructure, application product teams that know how to scale our services, but it's capacity planning. It's like how do we meet demand? How do we meet demand? You have to forecast what your demand's going to be, what your growth is going to be. So they're really excellent at being able to do that.
Got it. Got it.
Yeah.
Sounds good. And the other, I mean, I guess the other thing that I'd like to hit on before we wrap up the podcast is, so a few years ago, you had done, or Cloudflare. I don't know if you were working at Cloudflare at the point, but you had done for April Fools. It was aligned with April Fools, but it was when Cloudflare launched their own DNS service,
Yeah.
the 1.1.1.1.1.
Yeah.
And I remember everyone when that happened that day, like the internet went, like kind of caught on fire. I mean, not in a bad way, but everyone was like, is this like a joke? Like, were you at working at Cloudflare at that point?
I have been for April Fool's Day releases, and it's funny because people think it's a joke, and I'm like, no, 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 they actually release stuff. So it's like they introduced like a couple of years ago they introduced 1.1.1.1 for families, which I'm like, is this an April Fool's joke? But no, it was just like the fact that they have a DNS resolver specifically that will filter out adult type content or things that might be considered like so like they have one that's for no malware, which is 1.1.1.2, and then 1.1.1.3, which is no malware or adult content. And I'm like, no, this has got to be a joke. Nope, it's 100% serious. I'm like, so, but it's funny that they do that during April Fools because it's like people are not going to take you seriously. So how do you market this? But no, it's actually it's like the anti-April Fools. I'm like, what a way to like, most other companies might blog about something that's like non-realistic or anything like that. But no, we're actually releasing products and services on April Fools. So yeah, it's a gas, man. I just can't believe it. But yeah, that's what we do.
And I love things like that. For as we wrap up the podcast today, for anyone who wants to get in contact with Derek, you can find him at randomsecurity.dev, or he spends a lot of time on Twitter. And what's your Twitter handle?
The red in the sky.
Red in the sky.
Yeah.
Excellent. Well, Derek, it's been great to have you on the podcast today. It's like I said, it's been a neat kind of reunion of
Yeah.
7 years later of
We
everything that's
won't we,
happened
we
over that
won't we
time.
won't make it we won't wait another 7 years to do this again. So
No, we won't. No, we won't. Definitely not. And thanks everyone for listening. You can watch this podcast on YouTube, or if you have Spotify, you can listen to it on Spotify. We are on Google Podcasts. We're on Apple Podcasts. And I think there's one more, but I forget. But anyway, thanks again for joining, and thanks again, Derek.